Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch the fourth space-based infrared system satellite for the United States Air Force. Good evening and welcome to Cape Canaveral Air Force Station in Florida. I'm Amanda Cooker and I am a structural engineer on ULA's Vulcan Centaur program. I'm here in Mission Control at the Atlas Spaceflight Operations Center. The team is not working any issues at this time and we are planned for a liftoff at 7:48 p.m. Eastern. We have a 40-minute launch window this evening. A few seconds from now, the count will enter a planned 15-minute hold. There are 2 planned holds in our nearly 7-hour launch count. The planned holds give our team additional time to resolve any issues prior to entering the terminal count at T-minus 4 minutes. Later in the show, I'll be joined by Captain Kristen Cooper from the Space and Missile Systems Center's Remote Sensing Directorate at Los Angeles Air Force Base. Earlier this week, we asked our Instagram followers to post photos of past, present, and future military members in their lives, tagging ULA and using the hashtag SBIRS. Shortly before spacecraft separation tonight, we'll present a slideshow of these photo submissions to recognize the capabilities that satellites like SBIRS provide to American troops. Clay Flynn, the 45th Space Wing's weather officer, recently briefed the team on the weather conditions here at Cape Canaveral. The probability of violating launch constraints is 0%. The ground winds are 6 to 10 knots out of the north, and the temperature is 53 degrees Fahrenheit. So, the weather is within the launch commit criteria and looks favorable for tonight's planned T0 of 7:48 p.m. Eastern. Following a nearly 43-minute flight, the Atlas V 411 rocket will deliver the SBIRS GEO Flight 4 satellite to a geosynchronous transfer orbit. Let's take a look at the events we can expect to see in today's flight.
The following profile details the important events of this mission using approximate times.
5, 4, 3, 2, 1, and liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 main engine and 1 solid rocket booster ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 58 seconds. At 1 minute 11 seconds, the vehicle experiences maximum dynamic pressure. Shortly after liftoff, the Atlas V is burning propellant at a rate of 2,750 pounds per second, traveling at over 10,400 miles per hour, and located 63 miles in altitude and 188 miles downrange. At 2 minutes 20 seconds into flight, the single solid rocket booster is jettisoned. 1 minute 43 seconds later, booster engine cutoff occurs. The booster stage is jettisoned 6 seconds later. 10 seconds after booster separation, the first Centaur main engine start takes place. The payload fairing is jettisoned 8 seconds later. The vehicle now weighs just 8% of what it did at liftoff 4.5 minutes earlier. Cutoff of the Centaur main engine occurs nearly 14 minutes after launch. The mission now enters a 10-minute coast phase. At just over 24 minutes, the Centaur main engine is restarted. This burn will last approximately 5 minutes. Following the second Centaur main engine cutoff at 29 minutes 18 seconds, the mission enters a final 13-minute coast phase. At 42.5 minutes, Centaur releases the 4th SBIRS GEO satellite for the United States Air Force, providing early missile warning detection.
ULA is using the Atlas V 411 configuration to launch SBIRS GEO Flight 4. This is the 75th Atlas V launch and the 125th ULA mission. Produced in Decatur, Alabama and Harlingen, Texas, the Atlas V 411 includes a Common Core booster powered by an RD-180 engine, one Aerojet Rocketdyne solid rocket booster, and a Centaur second stage powered by an Aerojet Rocketdyne RL-10C1 engine. The satellite is protected during ascent by a 4-meter diameter payload fairing. On January 11th, the encapsulated payload was transported to the Vertical Integration Facility, or VIF, at Space Launch Complex 41, where it was mated to the Atlas V rocket. This activity completes the stack and is the last major processing milestone before final launch preps begin. The launch countdown begins with moving the rocket from the VIF to the pad. The quarter-mile trip began using 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the Mobile Launch Platform, or MLP, supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the portable environmental control system provides air conditioning to the payload and rocket. Finally, track mobiles provide the power to move the 3.5 million pound convoy. The Atlas V rocket stands 195 feet tall, or about 20 stories, and weighs more than 850,000 pounds fully fueled with its solid rocket booster. The RD-180 main engine and SRB produce more than 1 million pounds of thrust to lift the rocket off the pad and begin its journey to orbit. As I mentioned earlier, the Atlas V is launching the 4th dedicated satellite in the Space-Based Infrared System. SBIRS, one of the nation's highest priority space programs, is designed to provide global, persistent, and taskable infrared surveillance capabilities to meet 21st century demands in missile warning and defense, technical intelligence, and battle space awareness. The system architecture consists of legacy defense support program satellites, hosted SBIRS sensor payloads in a highly elliptical orbit, and dedicated SBIRS geosynchronous Earth orbiting satellites. The satellite constellation is supported by ground infrastructure, which receives, processes, and delivers the infrared information to key decision makers. Lockheed Martin is the prime contractor for the program, with Northrop Grumman serving as the primary payload provider. The SBIRS team is led by the Remote Sensing Systems Directorate at the U.S. Air Force Space and Missile Systems Center and is operated by Air Force Space Command. The artwork on the payload fairing of the rocket features an eagle, which signifies the Remote Sensing Systems Directorate. The globe represents the importance of this satellite, providing missile warning, which is the cornerstone of deterrence to the U.S. and its allies. Adopting the motto from the 3 previous SBIRS launches, Always Vigilant, Flight 4 logo reads, Semper Vigilans, a tribute to the SBIRS heritage. Today's launch is dedicated in memory of Eric Madison. Eric began his career at ULA as an intern in 2009 and as an employee in 2012. He worked as an IT architect and moved into cyber intelligence, his true passion. While completing his Master's of Science in Information System Technology at George Washington University, he worked closely with our Washington operations team, where he forged lasting relationships with our government customers. Eric willingly took on new and challenging assignments and set a high standard in terms of the quality he delivered to our customers. He was recognized as a rising star within the information technology organization at a very young age. His team members miss him every day.
SRB ignition enabled.
Verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Verify redline monitor and event table are in the correct configuration for terminal count.
Verified.
RC, verify solar radiation is acceptable for launch.
Verified.
L-minus 9 minutes.
Launch on time verified.
Roger.
L-minus 8 minutes.
LC switch to ready position. All steps are complete prior to the status check.
We remain in the planned 15-minute built-in hold as we continue to prepare for liftoff. In a few moments, launch conductor Dylan Rice will poll the launch team for the final go to pick up the countdown. 29 engineers and managers will be polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Dylan Rice performs the final polling of the team.
Status check to proceed with terminal count, Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2. LH2.
Go.
HASGAS. Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GC cubed.
Go.
COM.
Go.
Timer.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
CMD, you have permission to launch.
Proceeding with the count. Timer. Set count to start at 0044 Zulu for a planned T0 of 0048 Zulu.
Count will start at 0044 Zulu for a planned T0 of 0048 Zulu.
Polling is complete and the launch team has given the go for launch. From T-minus 4 minutes until launch, you will be listening to launch conductor Dylan Rice and his team performing the final steps in the countdown procedure. You will hear the team call out that Atlas LO2 topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur LH2 and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed by verification of Centaur tank pressures. A final status check of Atlas, Centaur, and SBIRS GEO Flight 4 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear the voice of Marty Malinowski providing launch vehicle ascent data.
On my mark, the time will be T minus 4 minutes and counting. 3, 2, 1, mark.
The countdown clock has resumed and we are go for launch at 7:48 p.m. Eastern.
T minus 3 minutes.
Securing LO2 top.
Atlas tanks to flight pressure.
2 minutes, 50 seconds.
FPS internal.
One minute, 59.
Vehicle internal.
155.
Launch sequence start.
150.
Securing Centaur LH2. Securing Centaur LH2.
1 minute, 40 seconds.
Launch enabled.
137.
FPS armed.
T minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
OCUs armed.
SCS count started.
115. 110.
Vent valves locked.
T minus 1 minute.
T minus 1 minute.
Rock, report range status.
Range green.
T minus 40 seconds.
Stable at step 3.
28 seconds. 25.
Status check.
Go Atlas.
Go Centaur. Go SBIRS.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition and liftoff of the United Launch Alliance Atlas V rocket carrying the 4th space-based infrared system for the United States Air Force. You are hearing the voice of Marty Malinowski providing launch vehicle ascent data.
throttled down as expected. Mach 1. Boosters throttled back up. Max Q. Coming up on SRB burnout shortly. Performance continues to look good. RD-180 chamber pressures continue to be steady. And we have indication of SRB burnout. Current altitude is 14 miles, downrange distance 11 miles, current velocity 2,622 miles per hour. Booster has throttled down as expected at this point in the mission. And the vehicle is now 50% its liftoff weight. RD-180 continues to perform well. Coming up on SRB jettison. And we have indication of jettison of the SRB. Looks like a clean separation. 2 alpha closed loop steering has begun. Booster has begun roll bias pointing. RCS pyro valve has been firing. That system is now pressurizing to flight levels. Signatures look good. Current altitude is 43 miles, downrange distance 94 miles, current velocity 6,691 miles per hour. Booster has throttled back as expected. Currently the vehicle is 25% its liftoff weight. Coming up on our 5G throttle segment. Boost phase cooldown is underway. Turbo pyro valve has been fired. Now throttling to maintain 4.6 Gs. Boost phase cooldown is complete, and we have MECO. We have stage separation. Oxygen fuel pre-start on the RL-10. GN2 purge firing is underway. We have ignition and full thrust on the RL-10. Yep. And we have payload firing jettison. Indications are a good jettison. RL-10 is burning at a set mixture ratio for the early part of this 9.5-minute burn. Chamber pressures, injector for fuel venturi, and discharge all look good. Centaur has now begun the closed loop PU portion of the burn.
This is Atlas Mission Control at T plus 5 minutes 30 seconds. Marty Malinowski just confirmed the successful completion of the early phase of today's flight, and all systems continue to operate nominally. The mission is currently in the first of 2 Centaur engine burns. Our next event, Centaur main engine cutoff, will occur in approximately 9 minutes. I'm joined now by Captain Kristen Cooper of SMC's Remote Sensing Directorate. Thanks for being here today, Captain.
It's such a pleasure to be here. Thank you for having me.
Of course. So we've just witnessed the successful liftoff of the 4th satellite in the SBIRS constellation. Can you explain a little bit about SBIRS and where it fits into the Air Force's space portfolio?
Sure. So the Space-Based Infrared Systems, or SBIRS, is part of the Remote Sensing Systems Directorate and is led by Colonel Dennis Bythewood. Each of our geosynchronous Earth orbit, or GEO satellites, hosts a payload which contains both a scanning sensor and a staring sensor. The scanning sensor continuously scans the Earth to provide 24/7 global strategic missile warning and missile defense capabilities. The data from the scanner also contributes to our theater missions and our intelligence missions. The scanning sensor contributes to all 4 of those mission areas as well, but its highly accurate and agile pointing and control system can focus in on any one specific part of the Earth, rather than scanning it continuously like the scanner.
So how does SBIRS fit into the Air Force's missile warning constellation?
So we just launched GEO Flight 4, so now we have 4 GEO satellites in space. We also have 2 payloads in HEO, or highly elliptical orbit, which have similar sensors to the scanner on the GEOs. With the 4 GEO satellites and the 2 HEO payloads, that makes up our SBIRS constellation. And they were designed to eventually replace the legacy DSP, or Defense Support Program satellites, which is an early missile warning program that started back in the 70s.
So how does this capability affect our troops on the front lines?
That is such a good question, because ultimately that's why our program exists, to support our troops and our nation. In today's global security environment, the number of threats to America and its allies is greater than ever. And as these threats evolve and change, the reliable and accurate detection of missile launches worldwide is critical to the defense and security of our nation. And that's where SBIRS comes in. SBIRS provides the global persistent infrared surveillance capabilities, even in an ever-evolving 21st century threat environment.
So obviously liftoff is a really exciting time for all of us. Can you share your excitement as we are starting to approach spacecraft separation here?
Yeah, that was so cool. This is the first launch I've ever been a part of, so I'm super pumped. And our GEO Flight 4 team has been working tirelessly to get to this moment, so I'm so proud of them, and huge congratulations to them. But really, this is just the beginning of the work. Now that we're in space, we have to run a bunch of tests and check out our satellite. So this starts with a series of liquid apogee engine burns to circularize our orbit, and then we will deploy several of our systems. So that includes our solar array wing assembly for power, our antenna wing assembly for communications, and then our deployable light shade, which protects our sensors from the sun. And then finally, over the next several weeks, we will continue to run tests and check out both the spacecraft and the payload.
So once you've done those checks and the satellite itself is operational, how does that capability enter service?
So as we complete our tests and calibrate our payload, we will boost our spacecraft into its operational orbital slot. And we expect to provide early data in about 2 months and receive missile warning certification in about 7 to 8 months.
It's great that we can get that capability up there so quickly. Can you describe your role in the SBIRS program?
Sure. So I am currently a program manager on GEOs 5 and 6, which are scheduled to launch in 2021 and 2022. I'm the systems engineering and integration lead. So my job is to manage all of the systems and processes for those 2 satellites. Most of my time right now is spent coordinating between the contractor and the customer to make sure our warfighters are getting the capabilities they need. I specifically volunteered for GEO Flight 4 because it's such a major milestone on our program, and it's a huge event for the SBIRS team. Those guys are making history, and I just wanted to help out in any way possible.
Well, thank you so much for all the information on SBIRS. We'll get back with Captain Cooper later in the show as we approach spacecraft separation. But for now, let's get back to the flight.
Range track continues to look very good. Centaur making good progress down the range. RL-10 operation continues to look very good. Mixture ratio controlling very close to nominal at this point. Hydrazine systems look good. Tank pressures and storage bottles do as well. Approximately 2 minutes remain in this burn.
This is Atlas Mission Control at T plus 12 minutes 16 seconds into the 4th SBIRS GEO flight. The Atlas Centaur second stage and SBIRS GEO Flight 4 satellite are currently located over the Atlantic Ocean east of Antigua. Our next event, the first Centaur main engine cutoff, or MECO 1, is scheduled to take place in about 2 minutes. Once again, here's Marty Malinowski.
550 miles per hour. One minute to MECO. RL-10 continues to look very good. All pressures as expected for the ZMR. Approximately 30 seconds remain in this burn. MAR has been set to fixed angles in preparation for MECO. And we have MECO. Engine shutdown looks good. We have 4S settling on. And we've begun the turn to MES2 attitude and begun the PTC roll at 1 degree per second. Fuel tank pressures have been vented down and are stable. Storage bottle pressures are stable. Batteries look good. Coast is scheduled for approximately 10.5 minutes, be followed by a second burn, which is approximately 5 minutes in duration.
Later this year, the Atlas V will launch astronauts to the International Space Station from U.S. soil on the Boeing Company's CST-100 Starliner spacecraft. Last week, I had a chance to talk with ULA's Commercial Crew Mission Manager for an update on the program. Let's take a look. We are here in Valor, which is the Vehicle Ascent Launch Operations Room, and I'm with Caleb Weiss, who is the Mission Manager for the Commercial Crew program. So, Caleb, the Atlas V CST-100 Starliner orbital flight test is coming up later this year. What are the objectives of that mission?
Well, orbital flight test, or OFT, will be the precursor to flying crew. So we will have the CST-100 Starliner capsule on top of the Atlas V rocket. We'll launch it just like we would a crew mission. It will go through ascent, dock with the space station, return to Earth, everything that a crew mission will do, minus the crew, and that lets us check all the systems out that we've designed for this mission. We get to review all the data, make sure it's the safest system possible before we put crew on, and then we'll do that with CFT, or crewed flight tests, later in the year.
So what is the current status of the program?
Well, both ULA and Boeing just finished their DCRs, or the design certification reviews, which is a big milestone and a step toward moving into the operational mode. So we've finished a lot of the non-recurring effort, the design work. Now we're building hardware. We have both our booster and Centaur in production in Decatur, Alabama. Boeing has their spacecraft in production at KSC. And so we're now marching toward launch in operations, procedure planning. We are doing all of our software and hardware qualification tests and working our way to OFT in August.
So you talked a little bit about the production and things like that. What is coming up next?
Well, it's going to be more of the operations planning. So we're going to be doing launch rehearsals. We're going to be doing all of our final analysis runs, all of our final reviews. We're going to be continuing the hardware qualification tests. So we have a series of integrated tests that we do with Boeing that involve both spacecraft and launch vehicle hardware. We have a loads test, acoustics test, jettison. We have a pad abort test, which will simulate the Starliner capsule aborting from the Atlas rocket. And so a lot of test objectives still to come, but all in line in working toward launch.
So you mentioned the abort test. What sort of scenario would cause a launch abort?
Well, part of Atlas V certification was to develop an emergency detection system, or an EDS. And what that system will do is have monitors all over the rocket. And if it detects anything that's off nominal or could pose a risk to crew safety, it will issue an abort. And the Starliner capsule will pop off of the rocket. It will deploy parachutes and return safely to Earth. So it's really a system that improves crew safety dramatically, and one that's been a large part of the design in the Atlas V human certification.
So aside from the EDS you mentioned, what other systems make the Atlas V safe for a crewed flight?
Well, we have some other hardware changes we've had to do. We have a new configuration and structure around the top of the rocket to help mitigate some of the aerodynamic loads that you get with the unique CST-100 configuration versus our traditional 4 and 5 meter payload fairings. We have a dual engine Centaur to provide extra thrust, so we'll actually have 2 RL-10 engines on the Centaur. There's modifications to the launch site. Most notably, we have a crew access tower there now, so we have a tower right at the launch pad that will be used to load the crew and cargo just prior to launch. And then we have just some minor changes to procedures and operations in the way that we're going to fly the rocket, the way that we're going to do our countdown procedure to allow for crew loading, things that are just making sure that we're conducting operations in the safest way possible for both the ground and the flight crews who will be working the mission.
Must be really exciting to get to work on a crewed mission. What is it like to work with the astronauts?
It's exciting. It really is. It's an honor to work with them. They're a great team of people. They are really invested in the mission, obviously. They provide great feedback. The entire commercial crew team comes with lots of experience in spaceflight. They give us feedback on data they want during ascent, communications that they think are productive to have during the countdown and the ascent. And so it's a really, really good team of people, and it's an honor for the entire company to be working with them. And we're all so excited to return astronauts to space from American soil. So we're moving towards OFT and CFT this year, and couldn't be more excited.
Awesome. Well, thank you so much for joining us, and we're really looking forward to the launch coming up.
All right, it's my pleasure. Thank you.
This is Atlas Mission Control at T+ 21 minutes, 26 seconds. We're a few minutes away from restart of the Centaur main engine. Let's go back to Marty Malinowski.
Centaur has completed that roll. With 2 minutes till MES 2, Centaur has now gone to 4S settling mode, preparation for MES 2 start sequence. LH2 and LO2 tank pressurization is underway. One minute to MES 2. We have fuel pre-start. We have LOX pre-start. We have ignition and full thrust. This burn is scheduled for just over 5 minutes in duration, followed by approximately a 13-minute coast to spacecraft separation.
As Marty Malinowski just reported, the Centaur main engine has been restarted for the second of 2 Centaur engine burns. This burn will last approximately 4 minutes. The Atlas V continues to travel in a southeasterly direction. Following our next event, MECO 2, or cutoff of the Centaur RL-10 engine, the Atlas V will cross over the African continent, where the trajectory will switch to an easterly heading. Separation of the SBIRS GEO Flight 4 satellite will occur over the Indian Ocean east of Madagascar. Listen in as Marty Malinowski reports the next mark event.
Off the stop and it's now controlling your nominal MR. Engine pressures have adjusted accordingly. Everything looks good so far. RL-10 continues to look very good. Our CS thermal conditions are excellent. Seeing our typical thermal conditioning firings, the proper intervals. Centaur tank pressures, bottle pressures, and batteries are all good. RL-10 continues to perform well. Centaur continues to accelerate at 1.1 G. One minute to MECO. RL-10 continues to operate well. Magazine system looks good, showing near nominal MR. And MR has been set at fixed angles in preparation for MECO. And we have MECO. Engine shutdown looks good. We have 4S settling. We have begun the turn to spacecraft separation attitude and begun our ETC roll at -1 degree per second. Centaur has now achieved its roll rate. Our fuel tanks have been vented down and are stable. Storage bottle pressures look good. Batteries are stable. Centaur has begun settling at a 50% 4S duty cycle.
Rejoining me is Captain Kristen Cooper. Great to have you back.
Thanks again. I'm glad to see everything's going so well.
So as you know, over the last week, we asked our followers to post photos of their favorite past, present, and future warfighters on our social media sites, and we got so many great photos in response. Let's take a look at some of those photos now.
Great. That was awesome. It means so much to me and our team to see all those photos and just how many people are impacted by our satellites. And I'm truly proud and honored to serve in the same military as all these men and women.
Absolutely. It's so great to see the faces of the people who are using or who have used the tools and the resources that we launch. For now, let's get back to the flight.
Centaur should be within sight of reef at this point in the coast. All Centaur systems continue to look good. Storage bottle pressures are stable. Tank pressures are as well. Still rolling at -1 degree per second. Still selling at 10% duty cycle on the 4S motors.
Next event, let's take a look at a video highlighting our 2017 launches. This is Atlas Mission Control at T plus 39 minutes 42 seconds. We're a few minutes away from spacecraft separation. Let's go back to Marty Malinowski for our final call of the evening.
Centaur has begun to arrest its PTC roll in preparation for spacecraft separation. Go under 1 minute till spacecraft separation. Centaur has begun spin up for spacecraft set. Now rolling at positive 1 degree per second. And we have an indication of spacecraft separation. Centaur has despun. Centaur has begun the CCAM turn.
This is Atlas Mission Control at T plus 43 minutes 12 seconds. Congratulations to the dedicated teams across the nation on the successful launch and delivery of the SBIRS GEO Flight 4 spacecraft to orbit. And congratulations, Captain Cooper, on a successful mission. Thanks for joining us today.
Thanks again, Amanda. It has been a pleasure to be here, and I just want to say thank you for letting me speak to you, your viewers, and your social media followers, and I'm looking forward to continuing with a successful SBIRS mission.
Of course. I'd also like to thank ULA's Marty Malinowski for his participation in today's show. For more information on the Atlas V, please visit ulalaunch.com or join the conversation on Twitter and Facebook. We'll leave you now with one last look at tonight's launch, which occurred at 7:48 p.m. Eastern Time. I'm Amanda Cooker, and on behalf of the entire launch team, thank you for joining us and have a great night. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition and liftoff of the United Launch Alliance Atlas V rocket carrying the 4th space-based infrared system for the United States Air Force.